G'day, it's Prezzo here and welcome back to episode 3 of the pull gear build. And I must say that since the last episode, this thing has just gone off. I owe a debt of gratitude to Mr. Pete because he linked to my build video from his restoration video, and that's given me access to all of his viewers, so that was great. And I did comment to Mr. Pete that we were sort of working on the same project concurrently, but just approaching it from different ends. So whereas he is restoring one of these devices, I'm actually re-engineering it and rebuilding it from scratch. And it's interesting to see as he reveals the interior components of this that it does actually look similar to what I'm doing. I had to work off the patent drawings, which don't show a lot of detail. In fact, there's a lot of differences between the patent drawings and the finished commercial article. And one, for example, is that the drive gear, which fits on this section here, on the original that gear was actually cut as part of this shaft, and on mine I've got a separate gear that's going to go over this section here. I think it's going to work, and I've had a lot of comments from viewers who suggested that the strength of this thing is important, that there's a lot of load on it, belt slippage could be a problem. And one of the issues that Mr. Pete alluded to in his video was that this thing is basically an oil slinger. And I understand that, and I've taken steps to try and avoid that. So one thing I have done is I've machined a recess around the edge of the ring gear, and on the inside of the cap there's a lip, so that when these two parts go together, the lip fits over that recess, as you can see there. So in effect there's no direct path between the interior and the exterior where the gap is. Now I thought I was being really clever and I thought that's going to solve the problem, but then I realized that any oil that gets thrown against this lip here, the edge of that lip, is going to run down, and it will end up in the bottom of the recess, and then the next time you start this thing up, that oil will get flung out as well. So maybe it's just delaying the process of the oil getting through there, I'm not sure. However, we'll find out when this all goes together. Some people have asked if I'm going to release the drawings of this, and yes, I will. I'll make the CAD model available and also the 2D drawings, but as I'm going along, I'm sort of modifying things and changing things, and I keep updating the 3D model to take into account those changes. One thing that I found was this boss on the top here I had much larger, and when I drilled through the holes for the 4 studs which support the planet gears, the inside set of holes was going to interfere with this outer diameter here. So I've reduced that and I've adapted the drawing to suit. I also didn't think to fit a brass bush at the top here, and you can see here the diameter of this shaft as it protrudes through the top of the cap is quite a bit smaller than the diameter of that bore there. So it's coming along. I think that mechanically it's going to work. My worry now is that the actual torque, if I gear this down 4:1, the torque might be too much for the poly V belt and it's going to slip. Now that in itself I'm not sure is a bad thing. Some people have suggested that I should have used a tooth belt, but with those you absolutely get a positive drive, and if a drill bit was to hang up or catch, you don't get any opportunity there to hang onto the part. It's going to start spinning. At least with a poly V or a V-belt drive, if there's a real disaster, the belt will slip and you've got a chance of avoiding some nasty injuries. Alright, so in this episode we're going to go on with the most critical part, which is drilling the 4 holes for the planet gears and making sure that I get all the clearances correct. And if that all goes well, then we might be able to see this thing running. So hang about, stand by. So you may have remembered that I said I was going to try and drill these gear centers into a piece of scrap stock. And I've got a piece of 3mm thick aluminium sheet here, and I've got one of these thin part vices on the CNC mill. this piece of timber here is just to support the stock when I drill through. And the thin part vise is nothing more than an L-shaped bracket. This one's made of cast aluminium alloy, and there's a rebate in one end of that L shape, and the other end has a moving jaw with a matching rebate, and there's a fixed block which is like a jacking block or a fixed jaw, if you like, or a fixed point from which you can drive that moving jaw along. So the stock sits in the rebates, and then push it up hard against the back of the L-shaped bracket there, and then lightly lock down this moving jaw, and then use your jacking screw to provide some end pressure. You don't need to overdo it. This is really just to locate this piece. And using this method, you don't have anything like clamps or any protrusions above the surface of the stock, so there's less chance of crashing the tool into anything while you're traversing backwards and forwards. So this is really good for drilling hole patterns in flat stock. Okay, well in theory they are my gear centers, so I'm going to take this out now and I'll drill and tap the correct size with those studs which hold the gears. This center position here I'll just drill out and ream, and I'll make a little like a spigot to go for the gears, the center sun gear. Okay, well here is the part that we just drilled on the CNC mill, and what I've done is I've bored out these holes 9/32, and then I've tapped them 5/16 by 40, which is a model engineer thread, but if you were doing this you could use any thread really, it doesn't matter. The interior hole, the center hole here, I've reamed out 8mm, and I've mounted the sun gear on a little spigot, and it has an 8mm pin on the end there, so I can rotate the sun gear in that plate. Now this is all just to test whether we've got the hole centers correct. Okay, so each of these little studs is going to get driven into that plate, and remember that all of these hole positions were taken straight off the CAD model, and I'm no engineer, so all I could do is look at the information I could get on the website where I bought these gears, which included the pitch diameter of each gear, and I've added on a 0.2mm clearance, or backlash if you like, and that should give us like a smooth running gear. And now the gears should mesh. Cool. So we get that, they mesh nicely, and yep, there's just the tiniest little bit of backlash or play there, which is good. Now, $64 million question, will the sun gear fit in there? Yes, yes! Ah, we having fun or what? Okay, now the next thing, the ring gear should engage on these two outer gears here. So let's see, what's the easiest way? Just give me a minute. Alright, I'm going to get some lube on this. And some people have questioned whether I should be using grease or oil. I don't know what the rotational speed of these gears is going to be, and I'm sort of thinking that probably grease will just melt and provide a lot of drag. So I may end up just using a good quality lubricating oil. Okay, just for fun, Yep, sprayed oil everywhere. Okay, so let's just see if this goes in here. Now remember, there will be a bearing in here later on to align this shaft. At the moment I'm just sort of having to wing it and try to get it correct. Yep, that's it. So, in theory, and why do I just put something on it here so I don't damage it? So the theory is that if this top plate were to be held stationary and we drive the centre spindle, the ring gear and the lower half of this pulley assembly should rotate in the same direction as the spindle, but with roughly a 4:1 reduction. So here we go. Yes! Now, I'm not going to lie to you, I already set this up and I checked it because I didn't want to look like an idiot on camera if it didn't work. And when that happened the first time, I literally ran around the workshop clutching onto my willy. I was that excited. So this gives me some confidence to move forward, and also the confidence to drill that same pattern of holes in this part here. The important thing is going to have to be that I get this centre bore here absolutely perfectly aligned. And on the CNC mill, I've got a probe that I can use to find that, but I think I'm going to check it with the dial indicator as well. And if that's all good, I can just go ahead and drill the same pattern of holes, no worries. Because we do not want to make any mistakes with this, and you know, do I make mistakes? Well, hardly ever. Okay, with that gear train working now, the next step is to replicate that whole pattern in the pulley cap casting, which I've got set up here now. And the next step is that I've got to get this center position exactly coincident with the bore in the pulley cap. And if I get that wrong, then the gears won't operate smoothly. So I've got my probe set up here, and I'm going to probe that larger diameter hole, work out its center, and then I'll check it with a dial test indicator. I'm using Mac Standard Mill as my operating software, and it's got lots of different probing options, but the easiest one is the probe hole center. So we'll go ahead and do that. And it should probe in X from right to left. Should now probe in Y. And we'll now probe in X again just to get rid of any error. Alright, that should be the exact center of that bore, and in Mac Standard Mill it shows that the diameter of that bore there is 35.02 millimeters. It's probably closer to 35 or 34.99, but I'm pretty confident we're pretty close. So just to be absolutely sure now, I'm going to set up a dial test indicator and run it around that hole and make any minor adjustments. Well, I'm not sure if you can see that, but I got my very expensive Michu Togo dial indicator set up there. And I initially used the probe to find that bore center, set the dial indicator up, and I found it wasn't right. It was about maybe 0.1 of a millimeter out, which was nowhere near as good as I thought it would be. I mean, that's an expensive probe too. So maybe I need to recalibrate that, but got me fairly close, and this is sort of dialed in now, and I've got that running at 0 pretty much all the way around. So I'm happy with that. Alright, well, I've got my spotting drill set up in there, and I've set my Z to 0 at that point, so it's clear of those clamps. And I'm just going to run this program on single step mode, and I'll use the quill to lower the drill bit. I've just got to take very, very light pecking cuts in this setup. You know, it's pretty good, but I'm not sure that it's going to withstand any heavy drilling process. Alrighty, just screwed up. You wouldn't believe it. That's drilled into the hole where the pin has to go. Damn! Okay, well here we are with another one of my famous cock-ups, and what I need to do now is to set this casting back on the table, but this time get the slot at 90 degrees to the front of the mill table rather than parallel to it. So all I can think of is I've jammed a piece of key stock into the slot, and I'm using a little T-square just to align that, and I can then lock that down and go through this whole process again. So yep, it's all going well. I thought all my troubles were behind me. Evidently not. What a laugh! Okay, so here we are, set up again. Can I cover up my mistakes? Probably not. That hole is going to drive me nuts. Maybe I can fill it with a plug or something. The other hole where the pin goes through the side here, let's call that an air escape hole or an air vent. Air vent sounds good. Okay, so we're going to try and drill the same hole pattern again, this time with the correct orientation relative to the slot. Well, that's done now. If it's messed up, there's not much we can do about it. So I'm going to change out for a 9/32 drill bit. We'll drill those out tapping size, and then we'll cut our threads. Okay, so let's get these started with the tap in the machine. So I'll drive the tap to each one of those hole positions, get it going, finish off by hand. I've turned the pulley cap over, and another feature I want to include here is a pair of tapped holes so that I can insert a 10mm pull stud, and that will allow me to get this cap off later on if I need to do any internal adjustments. On the original pull gear there was no facility for doing that. That was one of the reasons why Mr. Pete had so many problems getting his apart. So just thinking ahead a bit, I thought I'd add that feature, and you know what they say, if it ain't broke, it doesn't have enough features yet. So I'm going to just manually drill or spot drill my two positions, which are going to be 30mm either side of center, sort of 45 degrees across that center line, and I'll drill and tap and spot face. So I'll just do this really quickly so you can see it, but it wasn't worth setting up a CNC program to do this. It's just two locations and just changing out drill bits. I'll do the other one on this side, and I'll show you the whole operation with this one so it's a bit easier to see. So I'm just going to swap this out for a 10mm end mill to make it sort of a spot face, so that when I start my tapping drill, it's not going to be starting on the sloping surface here. Alright, so I'll get a 10mm tap started in there, and this will allow me to actually put a bridge across the top of this part and a extractor screw down the center, and then I should be able to just lift that whole cap off without sort of jamming anything underneath that cap or, you know, destroying it in any way. I'm going to take this off now and let's get everything fitted inside the guts of it. See how we go. One of the last jobs I need to do on this shaft is to mill an 8mm wide slot in two directions, so one in Y direction, one in X direction. One of those slots needs to be 10mm deep, the other one only needs to be 1mm deep, and if you watch Mr. Pete's video he'll show you how that latch can be either inserted into the deeper slot or lifted up and out of the top of the pull gear, and it just rests in this narrower slot, or the shallower slot I should say. And I couldn't think of another way of doing this. I've got this set in my 4-jaw chuck because it had a bore big enough to take the bottom of the shaft. Both my other chucks, the smaller ones at least, wouldn't allow that to fit down into the body of the chuck. And just because of its shape, it's really difficult to grip. And I wanted to minimize the overhang from the top of the chuck so I don't get too much chatter when I do this cut. I've dialed that in with my Michu Togo indicator, and I've zeroed my digital display at 00, which is directly over the center of the shaft. So I should be able to just traverse backwards and forwards in Y. I've locked the table down in X, get my 10mm depth, and then come back to 0 and do the other cut in X at a millimeter deep. So I know it looks super dodgy, but yeah, it'll work. So I've got one of the clamps resting on top of my vise, the other one resting on the table, and I've tightened that down, and I've aligned the part so the keyway that holds the gear on is against one of the jaws, and I've aligned the other jaws with the back of the mill. So not that it needs to be super precise, it's more cosmetic than anything else, but I did want to make sure it wasn't just a random setup. Alright, I think that cutter is really blunt, so I'm just going to change that out. I've got a new carbide one somewhere. I've just swapped it out for a 2-fluid carbide and increased the speed a bit. Oh, that's better. Okay, well that's 8mm deep, and I've just starting to rethink this whole design on this end. There's not a lot of material left at the top here, and if I was to cut an 8mm slot across that again in the X direction, there wouldn't be much left. So what I'm thinking about doing is cutting a much narrower slot. This secondary slot is really just to hold the latch up out of position and stop it spinning. And if I cut, say, a 3mm slot across there, that would be enough to hold the latch up out of its position I can cut a corresponding 3mm deep groove in the Y direction as well, so the latch will sit down where it's supposed to. So I'm just going to stop here now, and I'll have another look at the design. It's sort of getting late in the afternoon. This is the material I cut for the latch, and it's sort of a nice free fit in there, which is sort of what I want. So when I come back tomorrow, we'll see how we're going to finish this off. And it's often a case where you're sitting here modelling this thing on a computer and you're just pulling figures out of the air and sort of looking at how it appears on the screen. When you see it in the flesh, actually made out of metal, you realise that you may have gone a bit too small with the diameter, haven't considered how much strength this part needs at the top, and you tend to sort of design on the fly. And that's why I said originally I would release the drawings for this, but not until I've actually made all these little changes. Well, I had a meeting last night with the chief engineer, the designer and the manufacturer, and we've all agreed that we're going to cut this slot to 9mm deep. It's 8 at the moment. The 1mm remaining is going to be cut to 3mm wide, and then a 3mm slot cut across in the X direction at the top. And that very shallow 3mm wide slot is just to hold the latch up out of position and to stop it rotating on its own. So I'll go ahead and cut this 1mm deeper, and then we'll swap out to the 3mm cutter and do the rest of the cutting process. It's always nice to have meetings with myself in the evenings. Okay, so that takes care of the 8mm wide slot. So we'll swap out now and do the little skinny one. Alright, that takes care of the bottom of the main slot. So now we're going to reset to 0, 0 and do our cross slot. Only a millimetre deep. Okay, I'll deburr all of that, and then we have to modify this little latch to suit, so it's going to need a sort of 3mm wide ridge in the centre there, so I'll need to take a rebate out of either edge to match that 3mm wide slot. So there is the finished slot, deburred all of that. So it's going to make the latch to suit. One of the last operations I need to do on this pulley is to provide an access hole for this grub screw. This is what locks the spindle, which is the main drive unit for this pull gear, to the motor spindle shaft. So when this spindle's in position, it's sort of up in there, and the only way to get at that grub screw is through the side of the pulley. So this is one of those super critical operations. If I get this wrong, I just won't be able to get at the grub screw to tighten it up onto the motor shaft. So I'm relying entirely on the CAD model to get this part right, and it shows on the CAD model that I need 21.5mm from the edge of the pulley, and that's where the access hole would be. So that's the hex key that I've got to use. It's a little bit less than 4mm across the corners of the hex, and I've got a 4mm carbide end mill in the chuck here. So I set this up using my probe, and before I wind up here I'll actually show you the probing operation that I used to find the exact center of this part, which is super cool. So let's go ahead and provide that hole, and let's just hope we got it right. Okay, that's not completely through, but I don't want to tempt fate by breaking off that carbide bit. I'm going to swap out to a drill bit. Okay, now in theory that should give me access to that grub screw if I press everything together correctly. So I'm just going to put the probe back in and just show you this operation, because I was really impressed with the way that worked. Okay, so I have my probe set up over this outer diameter here, and it really doesn't matter which diameter you use, but the smallest one means less travel for the probe. So initially I put this part in the vise and I lined up the probe by eye to get it just 3-4 mil above the surface of the circumference here in Z, and roughly in the center of the diameter. Now I've measured that diameter, it's 50 millimeters, and I'm going to use Mac standard mill to probe the X distance here to locate the exact center. So this is Mac standard mill. Now if you already own Mac 3, you're probably saying to yourself, why would I pay extra for this? Because essentially it does the same job. So you can see here that in the run screen you've got all the usual controls that you'd see in Mac 3. So your G code appears here, you got your run, stop, rewind, etc. There's a screen here where you can load your G code, you can do all your tooling with this, so pretty much it's the same thing. However, when you go to the work coordinate offset screen, you find that you've got a whole bunch of different options here for probing. So if I scroll down through these do the the typical probing operations, finding the center of a circular pocket, but you can also do a square pocket, you can do a circular post and a square post. You can also probe in Z to find the surface. If I go forward to this one, you can also probe in X direction inside a pocket, or in Y. You can do up and over type probing. And if we get to this one, which is the one I'm going to use now, I'm going to use this operation which is called B center. So we'll probe down in Z, find the center of the circular circumference, then we'll probe in X, come down, find the center, then probe across to the right, locate the edge, back up and over, and so on. It does that twice. In order for it to know roughly how far it has to travel, you can put in a diameter hint. So in this case I put 52, so I know the diameter is 50. And over here you can see that there are a whole bunch of different options for probe speed, feed rate. In this case I've got 200 millimeters per minute as my fast feed rate. You can put in an optional slow feed rate, so we'll probe the second time at the slower feed rate. You can put in different clearances and so on. So all in all, it's sort of for me anyway, it gives me all these different options I didn't have previously. Okay, let's see if we can break the probe. Okay, so just found Z. Going to probe down about half the depth. Okay, just found X from the left. Now it's going to find X from the right. And it repeats that process. So if there was any error the first time you set it up, it cancels out that error. The second operation it does now, it sort of roughly knows where it is. And you may have noticed that the second time it probes in Z, it goes much deeper. It actually knows where the center line is. Okay, so that's the center in X. And the other thing I had to do is to find the edge of this circular face here. So there is a probing operation for doing that as well. So if we go to the next screen, you'll see that there is a probing operation here for Y. So it will just simply, if you press the green arrow here, it will just simply move in, touch that edge and zero off Y. If you press this green space up here, it will come down, find Z, move out, down and back in again to find Y. So yeah, max standard mill. It's not expensive. I think I paid about, I don't know, $80 Australian for this, but to me anyway it's worth it. Well, I just thought I'd give you a progress report before I finish up this episode. On the top of the pulley cap now, you can see that I've got my two 10mm threaded holes, and these can be used to extract this whole casting off the top of the rest of the unit. And these 4 holes here will eventually be fitted with a brass ball oiler, so I can inject the oil down through the studs to the idler gears. Also got the 8mm slot cut across the top of the pulley cap now, and that allows for the latch to fit into that, and that's going to lock the drive. Okay, I guess the more exciting development was getting these idler gears in place, and you recall I had to drill this pattern of holes, and that was super critical. If I got that wrong, none of these gears would mesh. Happily, that turned out okay. At this point, I think we need to get our alternative facts straight though. This hole is not a mistake. That's an air vent. This hole is not a mistake. That's a lightning hole to balance out the rotational mass. Just in case anybody asks, okay? However, let's have a look at this part. Now these are the studs, and what I've done is I've fitted a brass shim washer. Okay, let's just see if we can show you that. Brass shim washer, there it is. And what I was concerned about here was that the spur gears would be rubbing on this casting as they spin. So this little brass shim is really just to keep the spur gear clear of the casting. And I can tighten those studs using the cross hole. So when I do finally assemble this for good, I'll lock those studs down hard, and I'll probably put some Loctite or something in those holes, or at least a thread lock. And as you can see, the spur gear does mesh quite nicely. In fact, all the gears mesh nicely, which was a big surprise to me. I was pretty sure I was going to mess that up. On top, we got the bronze washer, and then we got our cap screw, which locks the spur gear onto its shaft. Now this might need a little bit of fitting to make sure that when this is locked down really hard, those spur gears still spin freely. That one's a little on the tight side, so I may have to just do some adjustment there, but I'm happy with that. So that was a bit of a milestone when I got that all working. I was quite happy. Also, the 4 idlers now fit inside the ring gear, and although you can't see it, deep down inside there I can see those spur gears spinning. It sounds a bit grindy, but eventually there will be no contact between the pulley cap and this bottom casting here. Okay, other developments. I've got the locking screw fitted now. That's the grub screw that will lock this to the motor shaft. We finished off the slot in the top of the spindle, and you can see now that the latch has its groove running down either side, and that will either lock into that position, or when it's rotated it locks into the 3mm groove on top, and that will just simply keep that in position so it's got no tendency to spin around and drop back into the latch unexpectedly. Okay, our plunger fits up inside there, and when the latch goes through that, I've still got to figure out some way of fixing the latch to the plunger, but at the moment that's all good. I'm happy with that. I also have a set of spacers. Now, when I originally designed this, the bearings were just simply pressed onto this shaft, and there was no actual positive location for those bearings. So with these spacers, which are just aluminium, they'll be slid on there, and then the bearings will slide up to each spacer, and that's going to keep everything accurately aligned inside the big castings. So those bearings are going on okay. They'll be pressed on eventually, or I may heat them, I'm not sure yet, but pretty happy with that. And the other thing that I made off camera was a bronze bush, and that's going to fit over the top of the spindle. It's still a little bit on the tight side. I need to do some adjustment there, and the same bush will fit up inside the casting, the cap there. So that's just an extra bit of alignment. And the only other thing that I did was to make the key which holds that spur gear in place. So I've got a piece of 5/32 key stock, and I milled a slot for the key in this diameter here, which is where the spur gear will fit over, and we've got our matching keyway in the spur gear, and that all goes on. That's going to be a tight press fit eventually, and once again there's nothing really to locate that other than friction, so when it's all assembled I'm pretty sure that's going to be okay. So we're getting to the point where it's all going to go together, and I'm going to wind this video up here because it's got to that 35-40 minute mark. And I noticed last night that Tubal Cain, or Mr. Pete, has tested out his pull gear, and from what I saw it was a success. It sounded like a bag of hammers, but I think his, being quite old, is fairly worn. The spur gears themselves were probably a bit notchy. But I think his consensus was that it did actually do what he was hoping, which was to increase the torque, lower the speed. And I think he was using 25mm drill bits in 25mm thick mild steel. And there were a couple of occasions when the belt slipped, and I'm expecting that too. But all in all, I reckon it's going to be an improvement. So thank you very much to all the people who have written comments. I've taken on board a lot of those. One in particular was this idea of fitting these threaded holes with the pull studs. That was not my idea, somebody else came up with that. And lots of encouragement from lots of different people. So thank you very much, and I'm going to see you on the next video, and for now, thanks for watching. Oh wait, I almost forgot. I'm sure what you really want to know is, does it actually bloody work? Well, watch this. Drop that in there, and come on, there it goes. There. So yes, it is driving that around. It's a little bit awkward to hold, but yeah, it's working. So stay tuned for more.